From the very beginning, we're thinking about speed.
With human hands.
It's a hand-built car. It's hand-built by people, not robots.
To build a car worthy of James Bond, it takes cutting-edge design.
It's certainly space-age technology in terms of the way that we build this car.
And artistic attention to detail.
That is one of the finest paint finishes in the world. It really is.
The result? A car of uncompromising quality. Built for power. Built for luxury. And built for speed. SpeedMakers, Aston Martin. In the 1964 film Goldfinger, super spy James Bond introduced the world to a British crown jewel, the Aston Martin. Extraordinary handling, awesome power, all built into a sleek driving machine fit for the world's most legendary 00 agent.
I mean, James Bond drives and owns an Aston Martin because it is the coolest car to be seen in. And James Bond is the coolest guy on earth, effectively.
But staying on top of the spy game and the automotive industry requires constant reinvention. A shining example of Aston Martin's innovative mastery is the DB9, one of the most powerful Aston Martins ever made. With a 6-liter V12 engine that pumps 470 horsepower and a 6-speed transmission offering race car control, the DB9 is capable of hitting 0 to 60 in 4.6 seconds. It's a license to own the road.
There's an effortless feeling to the car. You never feel as though you're really having to push the car. You run out of road before the car runs out of energy and power, if you like.
The blending of raw horsepower with superior handling and comfort makes the DB9 a devastating double agent. A luxury touring car that's also furiously fast.
To ensure that our customers get a fantastic car, whether they're going to drive that car on the road, whether they're going to take that car on a racetrack, you know, there's a number of test regimes that we go through to ensure that the chassis and the lineup of the car is absolutely spot on.
To build a car this incredible, it takes one of the most cutting-edge facilities on the planet. The Gaydon factory in Warwickshire, England.
What makes the Gaydon facility different to any other car plant that you'll visit is that it's not a factory. It's a clinical environment, it's somewhere that we're proud to work, it's somewhere that we're proud to exhibit. It's somewhere that when you walk into Gaydon, you know that you're going to get a quality product.
Close to 1,500 employees work at this 430,000 square foot facility, building the Vantage, DBS, and the DB9, Aston Martin's luxury grand touring sports car. DB9s are so exceptional, Aston Martin makes less than 1,500 of these hand-tooled speed machines each year.
Our craftsmen, our technicians, they pride themselves in quality. They pride themselves in building a beautiful car. There's about circa 200 man-hours that go into the assembly of an Aston Martin, and that gives us that little unique, special feeling that someone using these has created an Aston Martin.
The DB9 is one of the first vehicles to incorporate the groundbreaking vertical horizontal, or VH, structure. An ingenious concept that uses bonded aluminum and composite materials to maximize the rigidity of the chassis while making the car lighter, improving its handling while increasing its speed.
It's V8 structure, it's special to Aston Martin, significant just to Aston Martin because we use an adhesive and the panels we use are all aluminium, which makes it lightweight.
While most automobile factories use assembly lines to move cars through production, Aston Martins are built systematically at a series of sub-assembly stations grouped into 7 main areas: chassis build, body in white, paint, trim, final assembly, powertrain, and final inspection. At each station, technicians meticulously hand-build individual sections piece by piece. The entire build process takes a total of 25 8-hour shifts for a single vehicle.
Aston Martin means perfection. The best car in the world.
But it all starts in the chassis build area, where an Aston Martin chassis goes through 20 build steps before it's finished. To create the DB9's chassis, top designers took the classic lines of earlier models to new levels. Their goal? Keep Aston Martin's signature style and kick it up a notch.
It's all aluminium. 99% of the chassis is aluminium. So it's lightweight. Lightweight, which obviously more power, more speed.
The design is an ultra-light aluminum chassis of incredible strength. But to put it all together requires an army of expert craftsmen and special equipment even a secret agent would envy.
Not only do we build the chassis in a certain way that gives us overall performance, but the different composites and components that we use in the car obviously make our car as light as we possibly can make it with optimum amount of strength. We use various components, magnesium, we use carbon, we use aluminium and steel, and overall this is what gives us the performance of the car.
This dense layout of machinery, platforms, and conveyors is where the DB9 chassis comes together. Each step of the Aston Martin chassis build is designed to meet strict quality control standards, and it's all managed and finessed by human hands.
It's hand-built. It's hand-built by people, not robots.
As car components make their way from one sub-assembly station to the next, important parts are added. In order to ensure the right parts are ready at each station, they're first sorted out at the picking station.
This is a picking pattern. On the other side of this piece of metal there's a barcode. That box scans the barcode and it tells by that barcode what derivative we're actually building before it passes onto line.
This metal matrix holds individual chassis parts in place. As the platen moves down the line, technicians fill it up with specific parts depending on the Aston Martin model being built. All the parts are tracked by a computer that reads a barcode to know exactly which parts are on the platen and which ones come next.
What it does is you put the parts on it from the description on the screen and it carries the parts from here through the vision systems, through the robot cells and over onto the main assembly.
Often, workers need to add components by hand. In this case, rivet nuts are being drilled into a part for later assembly. All the instructions show up clearly on the computer screen. The vision system uses an optical reader to track auto parts. If a single piece is mishandled and placed in the wrong bin, this computer quickly turns into an electronic Dr. No.
It's essential you put the parts in the right position, because if the parts are out of line, it'll throw the whole part out. It'll go in now and it'll read the barcode and there's cameras, there's 8 different cameras in there checking for part positioning, missing rib nuts, missing rib studs.
There's no margin for error. If anything is out of place, the quality control vision system sounds an alarm.
It's telling me on the screen now that it's a DB9 coupe and it's running the test and it's telling me that fitting 1 is not okay.
That beeping is the equivalent of a stop down. The assembly line never continues without quality control making sure the build components are perfect at every step.
It's very important to keep the quality control as a high standard for Aston Martin because Aston Martin is built on quality. So it's very important to us to make sure the parts quality is correct.
At Gaydon, Aston Martin's modern manufacturing facility, workers have now assembled all the pieces needed to construct the chassis. For designers, a key challenge was keeping the weight of the DB9's vertical-horizontal frame light throughout the assembly process. Their solution? A space-age super adhesive, lighter than a traditional weld, and stronger.
It's built bolt-free, if you like, because our manufacturing technique is to actually bond. So we get a much stronger bond between two aluminium pieces than using a bolt to bolt those two pieces together. And that helps reduce mass and therefore weight. And again, it allows a little bit more freedom in the forms and the shapes that you can actually develop.
With adhesive so crucial to the car's structure, Aston Martin has to be 100% certain of its strength. To ensure each batch of adhesive is ready for action, a sample is put on a special coupon to test its effectiveness.
These are put together and then they're clamped together, then they go through the oven. When it comes out of the oven, the adhesive is tested on a machine to test the strength. And it's a pull test.
It's a test that's almost always passed with flying colors. In fact, the adhesive is so strong, until it dries, workers down the line must wear thick Kevlar gloves to avoid any contact with skin. But this mega adhesive is also lightweight. It's a major Aston Martin advantage. Using adhesive instead of metal welds puts this grand touring car in a weight class comparable with Italian supercars like the Lamborghini Murcielago.
Now the question I get asked all the time is this strong? Believe you me, the way that we put these cars together, this is aircraft technology. These cars are stronger than the traditionally built welded structured cars.
Once chassis sections are glued and clamped in place, heat lamps are used to begin the curing process. Like spot welds, this keeps the part together so chassis sections can be moved from station to station. Final curing will take place later. The two sub-assembly lines eventually feed into the main assembly lines.
Well, this is the front structure, was built on a sub-assembly. Once he's finished building a sub-assembly there, he lifts it up and puts it on a build plan. The left and right sub-assemblies are built in. Once they're built in the sub-assemblies, they come together on this main assembly.
When it all comes together, mathematical precision is so important, the final chassis assembly lines are called Geometry 1 and Geometry 2. Joining up at the central assembly line, the sub-assembled chassis structures are bonded together. The only precast part of the Aston Martin chassis is the windshield. At the windshield sub-assembly station, the cast metal gets prepped to join the main frame.
Yes, beginning of windshield assembly, there's a brace underneath, which comes from the picking line and has got adhesive added to it. And now he uses monobolts to secure the windshield assembly to the support frame underneath.
After 20 separate assembly steps, the final result is a fully assembled Aston Martin chassis.
Right, this car is now finished. It's all built up, it's gone through Geometry 1, Geometry 2. The windscreen assembly attached, and it's waiting to go into the oven to be cured.
Curing ensures the bonds forged earlier under the heat lamps are strengthened to the point where separation is virtually impossible.
Well, this is the main curing oven of the chassis assembly. Goes into the oven entry.
Each chassis is heated to 275 degrees Fahrenheit for 30 minutes. Once this cycle is complete, it moves on to the main curing oven, where the temperature hits a blistering 383 degrees.
Once it's finished its cycle again, it moves into the cool down.
After the bonding glue is fully hardened by the curing process, the chassis is moved to the body in white station. First, workers ensure the chassis is ready to receive its body panels. Some of the parts added to the chassis at this stage are special sound dampening pads. Made from butyl, these pads absorb engine noise.
With the engine the size that it is, you get a lot of noise inside the cabin, so this manages to cut down on most of the noise going into the cabin as much as we can. You want to enjoy the noise and just to hear the engine purring rather than anything coming through panels and rattling.
After adding the pads, workers prep the car for priming by removing adhesive and dust.
Wipe all the residuary rust off the top of the car to make sure that there's none in between it.
Since this is the final stage before body panels are attached, smoothing out the rough spots now is crucial. Ensuring perfection at this step can save hours of work later.
To make sure that everything is clean before I put the primer on, and as I say, make sure that all the pads are in place that need to be there before we do the panelling. If they're not there and the panels are on, then as I say, it's an awful long time to take a panel off.
Removing a panel can take more than a half a day, but with Aston Martin's obsessive attention to detail, mistakes are rarely overlooked.
The car is now finished, so now I'm ready to move the car on into the forward station ready for framing. It's finished, the car is actually prepped up. My job's done, I'm happy. I put my bit in towards Aston Martin, which we're all proud of. It's the British car, isn't it?
An Aston Martin chassis has been assembled, oven cured, and meticulously prepped for its next stage, paneling. This is when the final car will begin to take shape. To ensure the greatest structural and aesthetic quality of an Aston Martin, body panels need to have glue applied with laser-like precision. To accomplish this mission, the company relies on a special machine straight out of Q Branch, the panel adhesive application robot, also known as the James Bonder. By reading barcodes, this robot knows exactly which parts it's working on and where to place the adhesive glue bead. Unlike a human hand, it never loses the perfect torque, pressure, or output. Too little adhesive could weaken chassis bonds. Too much could gum up delicate fittings and die casts. The result? An adhesive application worthy of the name Bond. With glue applied, each panel is pulled from the panel adhesive application robot and placed into designated spots on special hydraulic presses. Hydraulic presses ensure perfect alignment. Once the panels are on, there's no going back. With glue this powerful, adjustment is nearly impossible. After the paneling is secure, the car is ready to move on to door installation.
Just getting the door ready to go onto the side of the car. Just putting the hinges on, putting the pads in.
The DB9 doors must be fitted with additional soundproofing pads.
They got all its mechanisms inside. When you sit inside the car, you don't hear them going, just it stops the sound.
For perfect alignment and careful installation, factory workers use hydraulic machines to do the heavy lifting. With the doors in place, workers finesse the fit and bolt the door to the chassis. With precision a top priority every step of the way, the gap between the door and the side panel has to come within millimeters of DB9 specifications. To get the fit exactly right, technicians attach a weight to mimic the weight of the fully assembled door. Next, they take measurements to make sure the door is flush with the rest of the car.
The gap from rear quarter to door is actually minimum 3.5 up to maximum 4.5 millimeters. And then it's got to be within a millimetre tape all the way down. So a good gap all the way, which it is.
Next, technicians make sure they have the correct gap space between the front fender and the front door. Once they're confident of the fit, workers lock the front fender in position. After the chassis known as the body in white. But before the body in white receives paint, it undergoes another round of intense scrutiny.
You can see on the screen you've got the CAD model, so you're comparing them from nominal to actual.
The CMM, or Coordinate Measuring Machine, works by using a computer model of a DB9 to compare points of reference with the physical car body constructed in the factory. The CMM checks every dimension and panel gap to make sure they fall within Aston Martin specifications.
Well, Aston Martin makes sure that everything is perfect and like to make sure all the body panels on the vehicle are put on in the correct position and correct orientation. So we have a 300 points per side to make sure everything is perfect.
Any imperfections found are immediately corrected by the factory craftsman.
There's a blemish. There's a blemish that needs to be adjusted in the bay over there.
I'd like to say that using the CMM machine and this modern day equipment is finding the perfect balance between hand craftsmanship and modern day equipment and technology.
I think one thing that you'll notice when you walk through our manufacturing process is that we're continually measuring the performance of the technicians and the performance of our product all the way through the process. At the end of the process, the car should be perfect. We don't want cars going to the end of the process that require, rework or finessing to get them right.
Once the body's deemed worthy, it heads to the paint area. Here, an Aston Martin gets its 7 coats of gleaming perfection by human hands. But first, each car undergoes hours of painstaking preparation. Each body's sanded and primed until its surface is as smooth as glass.
We use emery board or sanding paper. We use 400 sanding discs, and we go over it again with a 600 sanding disc.
The surface must be perfectly smooth. For a vehicle driven by the world's most famous secret agent, good looks and performance are equally important.
Not sanded correctly, you could leave contamination on the vehicle. The paint adhesion could also be affected. There's lots of things that could actually affect the paint. So it's crucial that it's done. Yeah.
Passing inspection, it's finally ready for the next step: priming and painting. Throughout the manufacturing process, Aston Martin holds a firm belief: some things are best handled by human hands. And the same is true when it comes to painting their luxurious rides. They spray, buff, and inspect just one car body at a time.
It's about 50 hours to paint an Aston Martin. It's over 7 layers of paint, and it's all painted by hand in the finishing process. I mean, literally in a black car, you can see your face.
It's obviously one of the most bespoke paint jobs in the world. I'm so proud of the paint jobs that we produce in this factory. I mean, just look at it. Look at that. It's absolutely beautiful.
Customers have 23 standard colors to choose from, ranging from subtle metallics to bright hues. Or, if none of these suit your taste, Aston Martin can match any color you choose.
Oh, this midnight blue, it's a delicate colour. Sometimes when I see the cars outside, I'm astonished. I think, wow, look at that. They absolutely gleam.
No matter what the color, a freshly painted DB9's carried from the paint room like a James Bond gadget. An unmanned forklift called an AGV, short for Automatic Guided Vehicle, glides precisely by laser guidance. Technicians summon the AGV to the paint shop by signal. Once there, it collects various models and transports them to 3-story shelving units, where the drying process continues until the next stage, final assembly. As each Aston Martin's chassis and body's assembled, inspected, and painted, they're moved to giant drying racks waiting for their chance to become a finished car. But this rest period doesn't last long. As soon as space opens at final assembly, an AGV is sent to fetch a painted body and move it to the beginning of the line. Here, technicians start adding interior parts, including additional noise and vibration dampening materials. But first up, connecting the electrical harnesses. Since the car's just spent 50 hours in the paint shop, it's crucial to protect its pristine finish. So Aston Martin technicians place protective panels on the body, allowing them to do their work without worry. After the wiring harnesses are snaked through the interior, the car meets one of its most critical driving components, the instrument panel. Instrument panels arrive here fully constructed. But before they reach final assembly, each instrument panel comes to life here in a multi-stage instrument panel build process that's full of challenging, intricate tasks. Technical proficiency and attention to detail are a must. After hours of labor at multiple stations, the final result is a fully constructed instrument panel, also known as an IP, but it won't be ready for an Aston Martin until it's programmed and quality assured.
This is the IP completed, and what we would do is put this over onto the electrical test and download everything, make sure everything's working.
A series of programs allow the instrument panel computers to interpret road conditions, vehicle performance, and driver input, giving and receiving critical information with efficiency and typical Aston Martin elegance.
We're pressing the green button to say that the stack unit is okay and we can advance.
With all the programming completed, the IPs put through a series of tests to guarantee the car will respond exactly as the driver intends. Any negative results are problem solved on the spot.
It's trying to find fault with any faults inside. Yeah. What they do now, it's asking me a question, are the lights lit? Which I will respond yes, because they are. Then we disconnect it all and it's ready for the line.
Back at the trim and final haul, the instrument panel's inserted into the waiting car, bolted in, and wired for action. In addition to installing the instrument panel, technicians also outfit the interior with some of the most luxurious items imaginable.
The interior of an Aston Martin DB9 is highly personalizable. It's all leather.
Consumers have 20 shades of leather to choose from, and because it's Aston Martin, only the best is imported.
High quality leather hides from mostly Scottish cows. That's important because they live along areas of land that don't have barbed wire, so the hides don't have nicks in them, so they are beautiful, beautiful hides.
Customers can also choose from 9 colors of carpet and 5 choices of wood trim.
All of the materials are authentic. The woods on the veneers are real wooden veneers. The metals, it is an aluminium piece turned from solid, so you get that nice cold touch, and everything has a really nice positive active feel to it as well.
From the cutting of the leather to the crafted wood, every interior element is handmade.
It's like wearing a tailored suit. It really is like going to Savile Row and having a suit made for you, and that's how you can spec the inside of the car.
As with the leather, only the finest woods make it inside the DB9. Walnut, mahogany, bamboo, tamo ash, or piano black.
Look at the interior. Look at that. That's lovely. The piano black finish. Look at here. Look at the face here. I could look at that any day of the week. Honestly, if I was a rich man, my car would be an Aston Martin. It really would.
What's in a name? Well, everything. When your DB9 contains an organic electroluminescent dash display. Imported from Japan, the layout uses technology normally reserved for high-end flat panel TVs. Dubbed an emotional control unit, even the ignition switch for the Aston Martin is unique.
The emotional control unit is our starter, effectively. It's real glass, real crystal glass. It's real stainless steel, has a fantastic feel in your hand, and it's actually what you use to connect with the car. It's also just a beautiful object to hold. So it's not a key, it's your connection, your emotional connection with the car.
With its instrument panel and wiring harness installed, this Aston Martin's ready for the next step, marriage. When it gets the parts it needs, to generate serious speed. Starting out as bare aluminum sections, the Aston Martins made it through chassis build, body in white, and paint to reach final assembly. It's now ready to receive its power. In his Aston Martin, Agent 007 can maneuver his way out of any jam he encounters. While the consumer model doesn't contain the whiz-bang gadgetry of a Bondmobile, it does have its own secret weapon, a brilliantly engineered 6-liter V12 engine.
You don't have to do anything like floor it to get it to go fast. You just give it a little bit of throttle and you're just going to ride that wave of incredible torque.
With 470 horsepower, the DB9 can zoom from 0 to 60 in just 4.6 seconds, reaching a top speed of 190 miles per hour. And it all starts here in Gaydon's powertrain area. Engines are shipped to the factory from Aston Martin's dedicated engine plant in Cologne, Germany. But it's here that the DB9's ferocious power comes to life. To start, a worker prepares the engine to couple with its transmission by installing a flywheel and clutch disc. Aston Martin positions the DB9 engine just behind the front axles. This allows its weight to be distributed to all 4 tires, increasing overall balance and traction.
When you're driving the Aston Martin, all the switchgear, the brake pedal, the steering, the shifter, all of those things are weighted just right, and they give you that feeling of real premium luxury. And that's what you really want from a vehicle like that.
This ensures the DB9 handles more like a race car than a GT. It's a design born from almost a century of racing experience.
Aston Martin's probably one of the most storied brands that ever came out of Great Britain. And they started out as coach builders with Aston Martin and Lagonda and built just amazing vehicles of all sorts of shape and size.
Aston Martin began with a dream. Build a race car as elegant as it was powerful. Back in 1913, that dream became a reality when founders Lionel Martin and Robert Bamford hand-built their first Grand Touring racers. Due to Lionel Martin's early successes competing in England's famous Aston Clinton races, the partners used the 2 names, Aston, Martin, to brand their sports car. For more than 2 decades, Aston Martins dominated the racing circuit. Only an event as monumental as World War II could halt their momentum. During the war, the company was assigned to making tools and spare parts for aircrafts. But soon after V-Day, the company was back in action. Under the new ownership of David Brown, the first DBs rolled out of the factory.
As they got into the 50s and 60s, transitioned over into being more known as sports car manufacturers and had great success racing and endurance classics like Le Mans.
Through decades fielding competitive professional racing entries, Aston Martin established an impressive pedigree, winning at Le Mans and dominating the international sports car racing scene. But Aston Martin wanted to make more than rarefied race cars. They wanted to craft roadworthy models for the racing aficionado. In nearly a century of operation, the company has changed hands. But Aston Martin's commitment to excellence has created a sports car phenomenon. And since the 50s, when the first DB models emerged, soon followed by the Aston Martin DB4, DB4 GT Segato, and Volante, the sleek Speedmobiles have secured their winner's place as some of the ultimate grand touring sports cars of all time.
All of the same technologies, all of the same things that they learned in racing, they put in the road car. And of course, then they did their wonderful coach building and they turned out that gorgeous interior and put in some sound deadening and all those things that we need to have to be a road car. But Was it any different than the race car? Not really.
By the 1960s, Aston Martin was well known among sports car enthusiasts. But to put the company on the mainstream map, it took a superstar of international espionage. James Bond first got behind the wheel of an Aston Martin in 1964's Goldfinger.
Who are you?
James Bond.
007s have owned and operated other makes and models, but no Bondmobile is more famous than the Aston Martin. For over 5 decades, James Bond has carried more than a license to kill. He's carried a license to drive an Aston Martin. But no matter who's driving the car or how powerful the engine is, an Aston Martin won't get anywhere without a transmission and drivetrain capable of putting that power to the wheels. After hours of finessing and fine-tuning, an Aston Martin body and chassis are nearly ready to get hitched to a road-ripping powertrain. But first, the car's engine needs to be fitted to its drivetrain. In the powertrain area, workers have just installed the engine's flywheel and clutch disc. Now, using a hoist, a worker carefully pulls in the next critical part, the torque tube. Made of cast aluminum, the torque tube serves a dual purpose. It houses and protects the drive shaft and creates a solid structural connection between the front-mounted engine and the rear-mounted transmission.
The torque tube gives it more rigidity and it stops wear and tear on both the engine and the gearbox.
Once that's complete, another powertrain technician adds the DB9 gearbox at the next station.
So you bring the gearbox in now to the torque tube. Put them together.
Gearboxes on a DB9 can be 6-speed manual for absolute control, or an automatic transmission with paddle shifting, called Touchtronic 2. Either choice is guaranteed to get your blood flowing. In order to completely lock the torque tube and drive shaft to the gearbox, bolts are tightened to specification 2 separate ways. To connect the drive shaft, the worker turns the crank to expose bolts through a hole in the torque tube.
Bolt in 3 ways in this position.
He marks the gearbox complete. All that's left to do before switching station is secure the bolts on the exhaust. Next, the engine, transmission, and torque tube are hoisted, set to receive their suspension system. As the powertrain begins to take shape, Aston Martin's brilliant design becomes clear. The engine and transmission sit just inside the front and rear axle, an arrangement that creates perfect 50-50 weight distribution, balance that leads to better traction and speed. Finally, technicians install all the necessary parts to the independent double wishbone suspension, including an anti-roll bar and anti-lock disc brakes. Now, it's time for a marriage made in heaven. The monster V12 engine and powertrain meet the Aston Martin DB9 body on its path through final assembly. The powertrain's rolled underneath, ready for the body to fly in on a conveyor. Workers take their time, ensuring every connection's executed perfectly. Once finished, this DB9 will be close to road ready. But before it's set down for the last time, it's given a set of gleaming 19-inch alloy wheels. Now the car looks like an Aston Martin, but it still has a way to go. Set onto a rolling platform, the car will receive its final interior components, like handmade contoured seats and Aston Martin's signature swan wing doors. The 200-hour build is nearly complete. As workers add the finishing touches, this DB9 has just one more step to pass before heading out the door. Final inspection. From a bare aluminum frame to a luxurious full-blooded sports car, the evolution of an Aston Martin DB9 is a sight to behold. The company's dedication to perfection is reflected in more than 1 million miles of testing and in factory standards that are among the highest in the industry.
We do hours and hours of not only road tests, but we do roll-on road tests, we do calibration checks to ensure that every single car as it leaves the plant drives absolutely perfectly.
Demanding personal accountability helps Aston Martin live up to its lofty standards.
My name is Barry Griffin. I'm a quality inspector. I do the final audit on the car and make sure everything's done right on the car. So basically we're here as a goalkeeper for the customer to make sure the car's good to go. If we're happy with it and all the rework's been done properly, we put our name badge on the car.
As James Bond has shown, beauty and brawn will always be a potent combination. But as times change, even the most legendary of names must tinker with the formula.
Every Aston Martin customer that I've ever spoken to is totally delighted with the product. So I think that we're on this journey really of continuous improvement. There's no destination, it is a continuous journey.
The future for Aston Martin is we will continue to develop the product range. We're introducing a city car, we're developing other brands around Aston Martin as well, and we will continue to develop beautiful cars into the future. It's not a fashion statement in Aston Martin, it's a timeless piece of design, and it's up to us to maintain that as a design ethos, that the cars are not here today, gone tomorrow. They last forever, and the design must stay beautiful forever as well.
Cutting-edge, racing-inspired spymobiles. Using the most advanced technologies, they take speed to the extreme. All the while maintaining signature style and elegance. SpeedMakers, Aston Martin.